Hello and welcome to our knowledge streams. Weather on southern Sweden is gloomy and rainy, which means the summer is over. That's the sad part. But the good part, we're back with our knowledge stream after the summer break. While you're here, I'd love you to like the stream, to encourage the algorithms to promote us and follow us or subscribe on whatever platform you're at watching us. We're now on LinkedIn, YouTube, and Facebook. And today we have a presentation on how we can make Kubernetes more enjoyable for developers by my colleague Per Ökvist. Per is our lead consultant and our expert on domain-driven design and distributed systems. I really enjoy his presentation style, so you're up for a feast. So without taking more of his time, Per, take it away.
Thank you very much for that introduction, and welcome back from a great vacation or vacations, I hope. So on that note, since this is our first stream, I think we're going to keep it rather light, so you could lean back and file this under inspiration. We're going to browse 4 to 5 different topics today at a glance. And the title I roped you in with was Orchestrated Containers meets Platforms as a Services and Serverless. But please note during this stream that you might be able to come up with a better title in your mind, and maybe that is a question for the end of this stream. So let's get started and see. In today's landscape, we are deploying applications in 5 different ways in this example. It could be code, it could be on function level, and it could also be in some way an artifact of packages. That could be the same packaging that you have for deploying code to your application, but you can reuse that also for deployment in some scenarios. And then we also have containers, and the runner-up would be the sandbox that WebAssembly offers up. But today we will be focusing on containers. And as an example, I'm going to use Azure here, but please note that when I'm using Azure an example, everything we talk about here is applicable to all major cloud vendors, but this is just to illustrate the point. So if we were to utilize containers today to deploy things into this cloud provider, there is a few different ways to reach the different services. Of course, the cloud provider's container registry or a public registry might be the central entry point. But then we also have complementary features, like a lot of the PaaS-like features or serverless features in Azure has support for Docker Compose. But when you move over to the more orchestrated side, we see that, of course, Kubernetes has Helm, or in this case also we have Service Fabric that has another manifest model for deployment. So even if the artifacts are containers, we are in a different landscape of what capabilities and how we want to use different deployment models. And that's something that we're going to look into today, how to make this easier depending on cloud providers. So there is also, in all major free cloud vendors, of course, the serverless capabilities of running containers on a serverless compute pricing model. And most of the cloud providers also goes into the trend of adding orchestration APIs like the Kubernetes APIs to serverless resources. This gives you the opportunity to run elastic clusters or complementary to your already running cluster. So you could scale up and down in bursts and apply serverless compute and pricing models to clusters. And this marries the orchestration APIs and those kind of services into a more serverless landscape where you actually could have orchestration of serverless resources. Then, of course, as we're going to talk about, what you deploy in these elastic clusters or serverless clusters or your own could also feature different application models. But today we're going to focus on containers as a deployment artifact, and Kubernetes in the sense joining the Cloud Native Foundation to have a stable and more common API across all vendors. So you're going to see Kubernetes as a cloud native standard. And that's the approach we're going to take here, to treat Kubernetes as a cloud native thing, and everything targeting Kubernetes in that sense could be seen as a cloud native approach. But there is a lot of different things lingering around social media, pointing out that Kubernetes is quite complex and advanced when you go into actually operating and owning different Kubernetes clusters. And this, of course, is common in our industry, that we are so good at adding complexity, even if it would be application complexity, or in this case, operational complexity. So as a developer, we want the best of what an orchestrator could offer us, but without any of the complexity. So we need something to elevate this experience. And a few also mentioned that Kubernetes could be, it's a platform for building other platform, or it's the operating system running the cloud. And I think both those sentences is going to prove themselves during this presentation, because we are going to look at how could we utilize Kubernetes as a platform and add tools that is more developer-centric and might hide away some of the more operational responsibilities in a more central manner. But operations could be within your company, and of course, some of the operations could move to your cloud vendor, and that is a balance that might be hard to strike. So be on the lookout for that during this presentation. But what is cloud native? So one definition could be that the cloud native application is a collection of interrelated but discrete components, services, tasks, and workers that, when coupled with configuration and instantiated in a suitable runtime, together accomplish a unified functional purpose. Quite a mouthful, but we have a few common terms here to be on the lookout for, like services, tasks, and workers. Those are developer-centric terms that we could feel familiar with. And the runtime, that is in this case, when we're talking about cloud native, of course, Kubernetes in some managed form, either on-prem, edge, or in a cloud provider. And together, when you have this bag of Lego bricks, we want to be able to deploy an application, but not tie ourselves maybe into a specific vendor, as long as we're using these terminologies. And that is the purpose and the goal to illustrate with this presentation. There are a few platform tools that might aid you in achieving that. And as a caveat, there is, of course, a lot of different tools, but we're going to focus on a flora of 4 or 5. But they are not the only ones trying to achieve that. We're also going to take 2 examples here. We were talking about developer-centric or application-centric. We're going to use the developer as our main audience. But when we compare these services and platforms, we're going to use the terms application team and platform team, and sometimes we're going to refer to things regarding the platform as operations. But when you hear the term platform, you might have heard platform team mentioned in a quite popular book like Team Topologies. And what we are going to talk about today, when we are more on the operations side of things, this could be interpreted and implemented both in your organization's platforms team, or depending on how close to just developing DevOps things, that might be an enabling team. So don't regard the referral to platform team as a one-to-one relation to the team topology view of platform team. So beware of that biased sense. So let's go back to developers, the application team. We want to enrich them and ease their lives in deploying more advanced workloads utilizing Kubernetes, but maybe not even knowing the underlying platform, making the sense that the Kubernetes is a platform for building platforms. But let's start with the application team. So the first thing to point out here, if you remember the schema I showed in the beginning, saying that you could, of course, use different deployment strategies also for Kubernetes, like Helm charts or something else. One of the challenges for a developer is to have a common way in describing the application without tying it to their underlying platform or the operation part of this. And one initiative to do this is the Open Application Model. This is one model for describing applications for deployment. In our case, we're going to focus on deployment on Kubernetes, of course. So in this picture, we illustrate a few of the common terms that we saw earlier. The application developer or the architect wants to run code in containers, and they want to describe this as components. Is it a service or is it a background worker? What is the thing I'm deploying, and what is the relationship to the application? But then we have a lot of more operational aspects, like canary releases, scaling, identity, traffic management. And then in this model, that is called traits. So the main two concerns for an application developer, it now becomes components and traits in defining an application without tying into the underlying model, as the picture here illustrates, that the Open Application Model is a model describing the underlying platform. And that could be Azure, AWS, GCP, Alibaba, on-prem, and in this case, as long as it is Kubernetes. But note that the Open Application Model also targets basically everything. We are going to talk about Kubernetes-specific scenarios, but this model has the ambition to describe all application deployments. So it could be IoT and edge, and of course mentioned on-premises, utilizing different services. And here we have the infrastructure operator. And later in this presentation, we're going to challenge this notion of how much of the platform team or the operation team resides within your company, your team, and how much of this could actually go to the cloud vendor, depending on what kind of service this could be implemented in. So to give you a glance into how this might look from a developer, here we have a declaration of the Open Application Model where you see we specify an application. And the application is central here, so that could be contained by multiple components. In this case, we see something named the public web and also something named the backend. So here we have two straight up components, but those components also has traits. In this case, we have a trait of a scaler. So even if this is a rather simple scenario, you get the gist of it, but then where declaration comes in describing your application and the types of workloads, and then that traits is only how you want the platform to cater to this without specifying that platform or those details. So this is very developer-centric, and that's the goal. And as I said before, the goal here is to have one model for describing these things, but you could have multiple targets in the future for deployment. But there are a lot of details that we're not going to dig into, because everything we're going to look at today actually could be its own presentation if we're going to have a deep dive on each of them. So let your vacation, post-summer brain just ease into this with a glance. So this is a focused model, focused on the application rather than the container or orchestrator, and that's the goal. We are putting the developer or the team in the front seat here, saying that that's what we want to aid to separate the operation concerns from the more application concerns, making it much more easier to describe your application. So that is a building block, but this building block is only a model or a specification, you could say. You need an implementation of the open application model to go somewhere. And in our case today, we're going to talk about the project Kubevela. And as the name hints, it has to ambitious, not ambitious goal, but a relation to Kubernetes. So this is the open application model's implementation, or a platform that uses that for Kubernetes deployments, as we're going to see. So this is actually the implementing project. The open application model in itself has no implementation, it's just a spec. So Kubevela implements this and also extends some capabilities. So in this scenario, we have the platform and the application team, where you have definitions of what components the platform supports. And the application developer, in this case, says, I want to deploy a web service with a route and a database and a back-end worker. But as you see here, this also then ties into the requirement that the application needs an AWS RDS service, a database service. So here you see Kubevela both managing the deployment to and mapping to Kubernetes, as well as setting up a resource defined by the operator. In this case, it seems to be an AWS database. So you get a lot more in the package that you could set up other cloud services, as well as managing your application model. And this example, it seems rather straightforward and simple, but remember, you are basically looking at an adapting project of the open application model into different targets. And that might look like this. So to be able to declare what components and traits your Kubevela installation supports, you could define those targeting different kinds of platforms or cloud vendors with a Kubernetes installation. So this could span on-prem, different offerings on the edge, or the major cloud providers, making it cloud native in that sense that you now could have an operator or platform team describing what components and traits that are available to you, or you could move that responsibility into imaginary services in the future from cloud providers, saying that these are the components and traits we support in our services. And a key part here is that you're basically mapping the open application model with the underlying control plane by Kubevela in Kubernetes, making it possible that you could set up components using Terraform or Helm chart or customize to be able to do your own PaaS platform, basically, internally. And that's why it's so interesting to imagine this be done by a cloud provider or an operations or platforms team within your company, making it very flexible. So you could define your own PaaS model on top of Kubernetes. So tying that together, we have the same scenario here, that we have the app team that delivers applications and apps with ease in this case, and then we have the platform teams defining and bridging capabilities and defining building blocks. So we could declare everything from environments to traits and components. And to repeat the difference you see here, that components are like, is this a work job? Is this a public-facing web service? Is this a database? And then traits becomes more the operational responsibilities in relation to that in your application. And then you could have different environments. So from the app team's perspective, they just define with the open application model what kind of environment, what application, and what components that application is made out, and how that relates to the defined traits. And that then becomes a deployment within Kubernetes. And as we could repeat, you just go back and glance here, you see that Kubevela and these things we're going to talk about executes as a control plane within the Kubernetes cluster. So we have talked about two different building blocks, one model and one implementation. And to sum up Kubevela here is that Kubevela is a Kubernetes add-on for building developer-centric. Here we have this developer notion yet again. It leverages the open application platform and the native Kubernetes extensibility to resolve a hard problem, making shipping applications enjoyable on Kubernetes. And that might be a bit salty, but as you saw those images from social media, there is a lot of complexity in Kubernetes. So making deployments easier would be really, really great from both an operational and application developer's perspective. So that's the aim of the Kubevela project. But let's add on to this imaginary world of a service that offers a flexible PaaS on top of Kubernetes that is developer-centric. We could add yet another building block, and this time we're going to revisit Dapper. And we talked about this in a knowledge stream, I think, last year within the 0.5 time frame. Since then, Dapper is released and is currently out in 1.3. So Dapper is very much production ready and alive. And let's see what Dapper offers in this scenario that we're talking about today. So we're going even closer to the developer now. So Dapper is a distributed application runtime that is portable, event-driven, and developer-centric. And this is something that you add to Kubernetes, but also the Dapper project could be used in process and in the future, maybe in other services or installations. So what Dapper offers developers is a few building blocks that abstracts away the implementation of service-to-service invocation, like service discovery, state management, that is your persistent models that we could talk more about what kind of persistence models that is supported. You have PubSub or publish and subscribe. You have resource bindings and triggers that making you reactive to different events in both application and environments. You have an actor model. You have observability. Distributed tracing is not a straightforward thing. And you have secrets management and, of course, extensibility of the platform. And what stands out here when we're talking about cloud native and developer-centric is that Dapper is not targeting any language. You could utilize the building blocks that Dapper offers up from any platform that could talk either HTTP or gRPC. Then language just need to invoke some endpoints that are specified, or the most popular platforms also have Dapper SDKs, making Dapper clients easier to implement. But what is the goal that you could achieve combining all these things what Dapper offers? So let's look at this scenario. You have your application and you have components in the Kubevela sense in form of, is this a web service or a worker? But then you have Dapper components. So Dapper is a sidecar to your application. And that sidecar implements a schema of endpoints for gRPC and HTTP where you could reach these capabilities. So let's say that you're running locally and you have the need for a state store or a persistence model. You could locally point that to one implementation, and when you deploy that to the cloud, you could change that by configuration, targeting a slew of different services. So now you have one specification. What are the common traits of a state or a PubSub broker or bindings and secrets that you utilize within the Dapper API through the sidecar, and the implementation is then interchangeable. So this makes it possible to combine deployment through Kubernetes and containers with a sidecar that then implements these kinds of components that Dapper supports, making components interchangeable, cloud providers interchangeable, and also eases development because SDKs goes out the window because the notion of SDKs are now residing in the Dapper implementation in the sidecar. So this allows you to look at the common components or traits of an application from a more centralized manner. So going back to Dapper on Kubernetes. So I'm going to skip forward to the complete picture here so we see some of the roles in play. Yet again, we have this notion of the operator. This could be the platform team or it could be the cloud provider. And as Kubevela, Dapper is installed on Kubernetes as a control plane with a set of services that fulfill what the Dapper platform aids you. And you have an actor partition placement that is only needed if you're running with actors. And then you have the Dapper runtime. You have some component changes, so you could upgrade and configure your Dapper. And you have certificates and identity. And this enables you to, on any Kubernetes cluster, install Dapper, either if it's today in any cloud provider or on-prem. So there is no dependency between Kubevela and Dapper. But as of now, in the version for Kubevela that is targeted 1.1, all the things configuring Dapper is now able to be exposed as traits in the open application model. So if you combine these three things, you could now define the Dapper configuration as traits in the open application model and use Kubevela as your flexible platform as a service on top of any Kubernetes installation. But imagine if someone aids you in doing this. So your platform team or operation team does not need to do the heavy lifting on their own. So to repeat, as a developer, the key things to take away if you're totally new to Dapper is the capability of components. Imagine replacing all SDKs with a standardized HTTP or gRPC call that could be aided in a Dapper SDK, but making all these things interchangeable. So you could go from secrets from disk to an Azure Key Vault in production without any application changes, making your container artifact containing your application interchangeable and adaptable to different cloud services, because those are now a configuration. And that is something that, as a developer, if the case is fit, seems really, really attractive. But we have talked about 3 building blocks where the open application model was just a specification or a model, and we have talked about 2 concrete things: Kubevela and Dapper. Dapper being the more application-centric capabilities, and Kubevela is more the glue between the open application model and your actual deployment, targeting Kubernetes in this case. A 4th building block could be KEDA. And KEDA is a Kubernetes event-driven autoscaler. And what could that be? Looking at this picture, you have the horizontal pod autoscaler already in Kubernetes, and KEDA utilizes that, but allows you to define and plug in external triggers. So with KEDA, you could have scaling strategies on workloads on a queue, something coming in from Kafka, or basically everything that you could define as an external trigger that is built in. So now you could see all these things coming together where you might have elasticity within your cluster. You have a developer-centric application model for deployment, but you could also scale this on a metric that suits your application or your platform. And that could be done through KEDA as well. And both Dapper, KEDA, and Kubevela, everything could be installed or used as itself in Kubernetes, but imagine tying all these things together. That could make up for some kind of PaaS service on your own or a future offering. And that is basically what we're going to delve into in the last part of this. Imagine that we now combine all these things and say we take the open application model through Kubevela, add Dapper, add Kada to some managed Kubernetes thing. Is that viable for new services? Is this a model where we actually see platform teams residing within your company doing all the heavy lifting, configuring cluster management, or could parts of these things move into the managed Kubernetes installations that is out from the different cloud providers? And you saw that both Dapper and the open application model has ambitions going outside the specific Kubernetes model and describing basically any deployment. So what does the future hold for PaaS services or managed services within your cloud provider? Could this be something that could be complementary to this picture, saying that it could spawn one or multiple new cloud offerings that lets you deploy things through the open application model and define Dapper building blocks using Kubevela under the hood to offer up what's promised in the beginning, Kubernetes as a platform for other platforms. But we could go even further with this mental challenge and saying that the declaration or the model for deployment over here in the open application model could be applicable to other PaaS offerings today as well. And the same goes for Dapper. Maybe some of these building blocks from this landscape could move over and complement today's offering or spawn complementary offerings. So this is not just one mystery box. It could potentially be a set of them. Or is the future moving the responsibility closer to you having control over the flexibility? But today, you might feel that the control and management of your Kubernetes cluster is a bit too much for the use case you have. And that's the main question that I want to leave you with here after your summer vacation, is that what could the future hold when we are talking more and more about cloud native things, and in some sense being able to move deployments from one cloud vendor to another depending on how we are selling our products, and the fine-grained, more catered services that is the competitive advantage between the different cloud vendors. What does this CNFC cloud native tools and platforms actually mean for the future of cloud services and bridging on-prem and edge, and making it easier for us to utilize everything that Kubernetes does so well, but at a cheaper price and a more app developer-centric way. And with that, I leave you now to think about what is the title in your head for this presentation. Is it really orchestrated containers meets PaaS and serverless, or is it, as Michał stated in the beginning, making Kubernetes more enjoyable for application developers? Or could it be defining your own PaaS, or the future of more standardized PaaS between cloud providers? What do you think? So please join us in the Q&A and see what you are thinking about the future in the aspects of these 3 to 4 tools I presented here today. Thank you.
Thank you, Per. We have a poll running right now, and it's really important for us to get feedback from you, so please vote on how you did like this session. Also, feel free to ask questions. We'll monitoring them, and we'll be adding them to our queue, and we already have some to Per, so I'm gonna go with them. With cloud services being abstracted, where does that leave the differentiation between those services?
Yeah, I think that is a really interesting topic, because as you see the different cloud vendors today, a lot of things looks the same, but there are key differentiators. That could be features in a message brokers. But as long as we have different tools to choose from, You might have scenarios when using Dapper and saying, oh, my pub sub broker should be defined as this more simplistic thing is totally right for you. Or you might need different key features that utilizes an SDK. So with this notion, simple things becomes more simple in the abstracted way. And the specific things is still a competitive advantage that you could go out and define in another way. But sometimes it's also features that could rely within the specification, but how it behaves or the pricing is two different things. But you see this trend. If we take Kafka for an example, that we have different cloud vendors supporting protocols where open source projects have become protocols, but the implementation might differ as long as they support the protocol. And Kafka is one of those use cases. So we are at a really interesting place from cloud vendors to cater up specific PaaS services that is unique for that platform, cater to these more cloud native and ease of deployment for complex scenarios, as well as implementing protocols, but having different underlying platforms for that vendor. So I don't have the answer, but the more choices you have, hopefully that leads you to a better fit for your application.
Yeah, and sometimes you're just already committed to one of the vendors, and it's good to have that vendor implementing that functionality.
Yeah, I think we should remember that a lot of workloads running in different clouds are probably rather simplistic. So this global scale use of Kubernetes and all those features is of course not for everyone, but making one deployment or one descriptive model for multiple things might aid adoption, but who knows?
All right. You browsed through a few projects and examples how they implement that way of working. Where could one go to get more information about those projects?
So since these projects are all open source and have active communities, most of them, if we take the open application model, they both have, together with Dapper, have these community calls on Zoom recorded to YouTube. So you could actually join and ask question live, or go to YouTube and see with a certain cadence the community and the team talk about development, thinking like a community stand-up. So a lot of these projects are really, really open and active. And some of them, like Kubevela, has their own channels in the CMC Slack team. So it's really easy to be engaged and informed. But if you want condensed information, the Kubevela site is really, really good documentation in the questions that we talked about today. How does it compare to Helm? Why are you doing this? What are you thinking about PaaS services versus Kubevela? The documentation answers a lot of these initial thoughts.
Right, and a lot of this is application developer centric. How much do I need to know about this as a developer?
More philosophical question. To be informed is always good, but imagine a future where the developer only knows how to write this OM spec model. That might suffice if you're deploying easy, simple things, but when we are talking about standing on shoulders on platforms and specs and building layer upon layer to be able to help you, of course, having a notion of what each layer does is good, but it's totally up to you how informed you want to be. But I think the scope that we presented here today gives a glance as a developers what's going to be able to build in the future to aid your deployments or aid your abstractions, moving away from complex operational knowledge. But all knowledge is good.
You talked today a lot about Kubernetes, and this is probably the most known platform for orchestrating containers. Are there any like competitors or other kind of projects worth looking into the area?
if you go to the CMC website, there is so much going on tackling different aspects of these things. But talking about Kubernetes, since Kubernetes joined the Cloud Native Foundation back in 2017, I think, we are now seeing that Kubernetes in itself is an orchestrating API that is seen as a standard. Of course, there are others, and there are a lot of tools that are similar to the tools we talked about today. So the flora is vast, but one thing that you could go and look into that actually Kubevela integrates and uses is this thing called crossplane, that it makes it able to you to set up cloud-specific services through this deployment declaration, saying that, as you saw in the example, that I'm going to deploy an application, but I need this RDS service from AWS. Who is going to set that up? Is that a Terraform script from my operator? Is this me? Now you could expose that up to the developer and making the adapters of those things work, so you could also control vendor-specific services when you declare what your application need. And that could also then be that you share that knowledge between two applications. So I think that is a common hurdle for application developers, reusing things and saying every cloud has its own way of deploying things, and then you have the more like Terraform cross-cutting deployment things. But you easily get into the real DevOps world, where you as an application developer knows maybe a bit too much about operation as well.
All right, thank you. Those are all the questions. Thank you very much for the presentation and answering the questions. And this is all what we have prepared for today. But we have already our next stream planned for next week on Tuesday, 31st of August at noon Central European Time. We'll have our colleague Jos Åkesson talking about the busting testing myth. And the stream will be hosted by Sarah, you know, from other streams. Once again, thank you for coming. Please subscribe and follow us on the platforms that you're watching us, so you don't miss any of our upcoming knowledge streams. And I wish you a great day. Thank you for visiting us today.
Thank you.
Here we go.